All right, so we're just about to go ahead and start working on our client framework. Surprisingly, it's not going to be a whole lot of work to do that. Unfortunately, though, there are going to be a couple bugs, actually, that I discovered while doing some stuff off camera and getting my own client system all set up and ready to go. Discovered a couple bugs, would have been resolved through testing. I know everyone, I should feel bad. But anyway, I guess what we gotta go ahead and do now is we gotta fix those bugs. I'm also going to slightly change something about, or a couple things about our server. And the reason for that is I did actually find a way that we could reuse a lot of components between the server and the client. Now, unfortunately, we're not going to go through that process yet. I want to get a bunch of other stuff done first, and it's at some later point, once we have some more things that we can work on the actual game, having people run around, all that fun stuff, we'll go back, take a look at the server, get some stuff ironed out a little bit cleaner, because most of the server was kind of written with me just throwing stuff together. But there are a couple things that will impact the way that we write the client, so I decided to change some of the aspects of the server. So yeah, in this video, we're going to fix some bugs, and we are going to change a couple things about the server. Not a whole lot. It's not that scary, so don't worry. Okay, so starting off with bugs, let's go ahead and look at the component proxy generator. Now with this, I unfortunately probably was, brain dead when I wrote this, but on both the proxy generator invocation as well as the method name itself, I'm saying create interface proxy with target. Now, that's actually not what we want, unfortunately. We don't want to have a target object. We want no target. Effectively, the object that we want to use is going to be the object generated by Castle. Now, the reason why this worked, and the reason I didn't notice it earlier, is what's happening here is the create interface proxy with target has a generic overload, and we are getting an instance of generic typing here. Basically, we are getting this overload, and we can know that because the type here is grayed out, ReSharper is saying that the type declaration is redundant. So the interface type is actually not being passed into the interface type parameter. As you notice, it's being passed into the target parameter, which is typed to this generic parameter, and then our interceptors are passed in as well. That's why the syntax worked. Unfortunately, it is not the method that we want. This will throw an error because it'll try to use the object type as a target for the proxy. We don't want that. What we want to do instead is, go ahead and remove that because we don't want that right there. We are going to be using the create interface proxy without target. So I added OUT right there after the with right there. So what we want to do is, if I come over here and verify it, if I hit Control Shift Space, we see that we are now using this overload that's highlighted on my screen right now, which indeed is the overload and method that we want. In addition to changing the name of the method that we invoke, I also want to reflect that change in the name of the method itself. So we're going to change this to create interface proxy without target as the name of the method. Now you'll notice that we will be getting an error here because we do use this method on the server. We'll fix that error a little bit later. I want to stay in the infrastructure namespace for a moment here. But just remember, we're changing the name or word without to get the behavior that we're going to be looking for. Okay, another thing that I overlooked is on our system type registry class, I do want to go ahead and add an attribute selector. What do I mean by that? Well, when we scan an assembly or an app domain, I want to be able to pass in an attribute that will be used to filter out particular types. So instead of scan assembly, we will we'll also pass in a type that refers to an attribute that'll be used to filter out types. We really need that because as I was playing around with how we're going to actually test this, I noticed that there were a lot of cases where I'll have these tests, and some systems need to be registered to one thing, and some systems need to be registered to another thing. And we need a way to differentiate between where we want our systems to be registered to. When we do a whole scan assembly, we'll be getting every single system, and there will be no way to filter them out. So, what I'm going to do is I'm just going to put in a type here. Well, no. I want to make 2 overloads. So what we're going to do is I'm going to stub out these methods first. First of all, I'm going to change the signatures. I'm going to say type filter system by attribute. Or how about attribute filter? So we're adding that to the scan app domain method of this system type registry class, which is located in our infrastructure namespace. And then on the scan assembly, I'm going to add a type attribute filter. Now, before I go ahead and actually fix these 2 methods, because right now they're not going to work, I do want to go ahead and add a couple overrides, or overloads, sorry. I'm going to say public void scan app domain that takes in no parameters, and it's going to invoke scan app domain with the argument null for the attribute filter. Now, I'm going to go ahead and do the same thing with scan assembly. I'm going to say public void scan assembly, type, or sorry, no type, just assembly, and it'll pass in, or it'll invoke scan assembly null. And that's that. All right, now let's go ahead and fix our actual methods. Let's start with scan app domain. How do we fix this? Well, we're simply going to say scan assembly, and we're going to pass in attribute filter into that method invocation. All right, so scan app domain, pretty straightforward. For scan assembly, we actually have to take advantage of the attribute filter. So what I'm going to do is inside this for each loop, I'm going to come here. After we ensure that the object, the type is a class, we ensure that it's not abstract, and we ensure that it is implementing iSystem base. I want to ensure that if we passed in an attribute filter, that we should go ahead and do the stuff. Filter it out if it doesn't have that attribute. So I'm going to say if attribute filter does not equal null and not type get custom attributes type of attribute. Oh, come on. Attribute. Yeah. Oh, why am I doing a type of there? I don't know. I'm blind. Also pass in false, and then do dot any. Now this will import system.link, so if you don't have a sharper, make sure you add a using link at the top of your file. And then I'll say continue. So if the attribute filter is not null and the type does not have that attribute, continue. A couple things to point out and talk about, I guess, because I guess this is a good segue into a small design discussion about code. You will notice that my if statements seem to be inverted, I guess you could say. You might be thinking, well, why am I testing the negatives? You know, why am I saying if it's not a class or it's abstract or it doesn't do this, then continue the loop? And why do I say if we have a filter and it doesn't match that filter, continue? I could have just did 2 nested if statements. Well, the reason for that is you should really sort of conceptualize your code as in a very procedural manner. And I don't mean procedural in the sense that we're lacking objects and this isn't an object-oriented language that we're using. I mean procedural in the sense of your methods should be about one thing, and it should happen in sequence, and you should have this concept of what some people refer to as a happy path of execution. So your method should do one thing, but it's possible that your methods may exit or not perform an action in a loop or do any other sorts of things based off these conditions. It's possible that that will happen at some point. What you need to do is you need to identify what is the happy path, what is the positive path of execution, and have that be at the near bottom of your either loop or your method. And what that does is it makes the code significantly easier to read, because I can, easily scan through a method and say, well, obviously this method does this thing at the end of it, and there's a bunch of preconditions and maybe some post-conditions inside the method, but I can just mentally kind of block those out because those are edge cases. Instead, when you see a method, you should see like I said, the happy path, the path that you're expecting to enter. Now, this sort of concept might seem a little contrived in a for each loop, because what is the happy path of scan assembly? Well, you could say it's to execute this for each loop, but you could also argue that within constructs themselves, such as for each loop, you can say, what is the happy path of this for each loop? And the answer to that question is what this for each loop effectively does, it registers system from concrete types. And that's what the for each loop does. And if there's ever a condition in which that can't happen, we continue the loop and we just skip over this line. So the happy path for this loop is going to be right here, and we want to put in some preconditions up here to ensure that systems aren't registered if they don't meet particular criteria. So that's why you'll notice that I use a lot of inverted if statements, places where people would just do if, nested if, nested if, nested if, nested if. That leads to some really bad code. I'm just pointing out, really focus on what it is your method or loop is trying to do, and make your method or loop do one thing, and then filter things out from entering that one thing based off some conditions. Really, that's about it. I mean, yeah. You'll see that pattern is pretty much present in almost all code that I write. If I look at the constructor, for example, we filter out interfaces, then we do something with that. Anyway, the second thing I want to talk about is going to be, well, I mean, I guess I can point out usage of link, because if you have ReSharper installed, it'll want to do something like that. And I don't really find that as readable. I mean, I sort of have a love-hate relationship with those sort of constructs. I find that reducing the amount of vertical space that you use increases readability of code. Breaking out conditionals like this into related blocks also increases readability of code. Yes, I could have taken this, and I could have put it in this same if statement, not having to repeat an if statement and a continue, but it wouldn't make conceptual sense and make the code uglier. But anyway, so the next thing I wanted to point out is if you do have ReSharper installed, it'll be telling you to make the scan assembly the type attribute filter optional, which is a feature of .NET 4 and is also present in .NET 4 compilers even if you're targeting .NET 3.5, because it's a compiler feature. It's not a runtime feature. It's something that C# kind of adds on the whole thing. I am not a big fan of optional parameters because I don't like the way in which they were implemented. You can run into some really nasty circumstances where you have you break compatibility with binaries by introducing optional parameters and then changing them. And the reason that is like I said, optional parameters are a compiler construct. Basically, an optional parameter is nothing more than if you don't put in a parameter at a call site, the compiler literally just copies and pastes the default value and dumps it into the call site for you. It's not something that's handled by the runtime, meaning that if you, like I said, if you change the way the optional parameters work and you don't recompile things that depend on that code, or the other assemblies that'll depend on that code, then it's really nasty. In fact, I'm really curious as to why ReSharper would be suggesting this anyway, because it's actually against Microsoft's code style guidelines to use optional parameters in anything other than private or internal methods. So the fact that ReSharper is asking me to turn this into an optional parameter on a public method in a public class that is referenced in other assemblies is not a good thing, and I highly discourage people from doing that. In fact, I'm just going to go ahead and change the inspection options. Just do not show. Don't tell me what to do, ReSharper. Okay. So that's our system type registry. Let's go ahead and talk about the component map. We spent a lot of time with this guy. I ran into a small design problem with the client framework due to the fact that the reserved component ID limit is something that happens at construction of the component map. So when you construct the component map, you have to provide this reserved component ID limit. Now that works fine on the server, and I'm going to leave this constructor in here, but it doesn't work so fine on the client. In fact, the client, typically the workflow that I went through, or the architecture that I went through, the client will instantiate his component maps before he receives instructions from the server as to what those component maps should look like. Meaning we need some sort of way to expose the reserved component ID limit as something that can be set after construction. So what I'm going to do is I'm going to introduce a method. I'm going to say public void set reserved component ID limit int byte reserved component ID limit. Then I'm going to say reserved component ID limit equals reserved component ID limit. And I'm going to say next auto mapped component ID equals math dot, oh, I always get these mixed up in my head. Max, yeah, what do you want to max? Reserved component ID limit and next auto mapped component ID. In addition, I will change the constructor. So instead of setting reserved component ID limit here and then setting the next auto-mapped component ID, I'm going to remove these two lines entirely, and I'm just going to depend on the set reserved component ID limit method. Now you might be asking me, why am I doing this inside a method and not the property itself? Because we already have a property right here, and I could quite easily have turned this property into a property with a backing field and put this logic inside of the setter. The reason is I have a big problem with the mutability of classes, being able to change the way or the data inside of a class after its construction. There's obvious cases where this is desirable, but you'll find that in most cases it's not. And I think it's part of the responsibility of the designer of a class to use the constructs of the language that they have to express how the class should be used. By making the setter of reserved component ID limit private, we're indicating to whoever uses this class that we shouldn't necessarily be setting that on a frequent basis. It's not a data member. It's just it's a thing that this component map can do. In fact, the only reason why it's exposed at all, I believe, is for testability. If I look at, the only reason we even expose this is so that we can put it in we can serialize it down and we can test it. So I don't want to give people the impression that they can go around changing reserved component ID limit all the time, but I do need a way to actually set it. Actually, you know a better idea would be to keep this all as it is and make this internal. I don't know why I didn't think of that. Because the only thing that's going to be invoking the set reserved component ID limit besides the constructor is going to be the binary formatter, the component map binary formatter. Making this internal pretty much gets rid of this whole discussion. But just to complete my train of thought from earlier, I find methods always carry more weight. They carry more mental weight than properties. Properties are just data. You get them and you set them. They feel like fields. You should sort of treat them like fields. Methods are doing something. They're messages. You're telling the component to do something, to perform some action, and you're not entirely sure how complex that action could be. So I like using methods instead of properties for setters in the case where I want to discourage people from changing the data. Because every time I do something like this, obviously, every time I have to make a setter method for a property that has a getter already on it that's public, it feels a little kludgy, but I think that's kind of the point. It's to put a red flag on discouraging the clients of this class to use that method. And I think that's really, really important, especially considering that a client of this class includes you and me in this case. Anyway, making it internal actually makes me happy, because now we won't be able to invoke this method from anywhere outside this assembly, and everything is awesome. So now let's go into our binary formatter. Because again, like I said, our client framework is going to instantiate his component maps before he'll get the message from the server indicating which components are mapped where. So we need a way to load in a component map that doesn't instantiate itself, that takes in an existing component map. So what I'm going to do is, I don't want to get rid of this load method, so I'm just going to change things up a little bit. First of all, I'm going to make this load method return void, and I'm going to make it accept a component map as the second parameter. And I'm going to call it map. Now, I'm going to remove this return down here. Then, I am going to delete this instantiation of component map and replace it with map.setReservedComponentID reader read byte. So we've just turned this method in to from something that returns a new component map into something that acts on existing component maps. Now, of course, this is going to break all of our tests. So to fix that, I'm going to add an overload to load. It's going to be public component map load binary reader reader. What this method is going to do is I'm going to say var map equals new component map, passing in no reserved ID limit, invoke load, passing in reader and map, and then returning map. And that's it. So now we still support the old API of being able to instantiate a component map from a reader, but we now also support being able to modify existing component maps, which fits nicely with the way I want to use this on the client. And that's actually really about it for our infrastructure namespace. So yeah, I think that'll make things... we have a class that we're going to add in here later, but that's a class that's specific to this client system, so I'm not going to worry about that yet. Let's go ahead and close all our documents, because I don't like leaving in... It just really irritates me when there's 1,000 documents open. I don't know how people can work like that. Let's jump to our server. So our server has a couple bugs, and it has a couple things that I want to change. So this shouldn't take too long. If I go into the event class, we can locate a bug. Do you see it? Maybe you want to pause the video and see if you can find the bug here. It's actually highlighted on my screen because of ReSharper. I usually, anytime ReSharper highlights something, I usually always just gravitate towards that and fix it, so I get a nice little green check mark up here and no little notches, but there is a bug. Okay, well, I'll just tell you. Right here, data's grayed out. That should instantly raise a red flag in your head, because data's grayed out, that means this method doesn't use data. If this method doesn't use data, how is the data getting into the event data class? Well, the reason is I accidentally typed send parameters in the event data constructor as a second parameter. So you'll notice if I hit Control-Shift-Space, the reason why this did not throw an error is because this second parameter also has an overload that accepts object, as in addition to the overload that accepts a dictionary of byte and object. However, we don't want to just serialize down our send parameters. That seems kind of dumb. So instead, we're going to pass in our data parameter. And now our data parameter is no longer grayed out, and this should work. Okay, so next up on the list, there's something about the iServer transport that I ended up not liking when I went ahead and built up the client framework. One of my goals with this entire system is to be able to have the entire system, both server and clients, in memory running in a mostly single-threaded manner for testing purposes. I want to be able to, in a test, spool up a server object, connect clients to it, but have all the transport happen in memory and not over an actual network. So I ran into an issue with I wanted to separate out the concept of serialization of our primary data structures from the concept of actually sending that data. So I want there to be, the server transport is actually an improper name here because, yeah, we have the send data method, that's great, but our send system response methods, these methods are getting in fully fledged objects. In fact, these methods are only useful for sending system responses. What if there's a case where you want to send an operation response that isn't a system response? Well, you have to add a new method here. So basically is what I'm saying is that there is a disconnect between the level of abstraction with this interface. We have our event class, which contains an event code and a dictionary of byte and parameters, but then we have this stuff. Not only that, notice how I have result bytes here? I don't know what I was thinking. Why would I expect the server transport to serialize the IRPC response, but I've already serialized the result bytes? I mean, does that make sense? I don't know. It really started to irritate me, and this problem with the level of abstraction made testing more difficult, because then in my testing code I had to repeat myself in how I was going to serialize the IRPC response. So instead, what I'm saying is that I want our sending system responses to match the level of abstraction as our send data method, which is to say I only want these methods to return, or to accept, an operation code and a dictionary of byte and object, so that whoever invokes this method has already performed that logic and we can reuse it in different circumstances. This also means that I don't need to overload this. In fact, what I'm going to do is I'm just going to nuke both of these methods. I'm going to start fresh, just nuke them both. We'll clean up the code here in a second and the implementation. And then I'm going to say void send operation response. Notice the change in terminology. Passing an operation code and a dictionary. Remember, this brings in system collections generic. Byte object parameters. So now we have a more coherent level of abstraction, and this significantly, or in a significant way, decreases the amount of code we would have to do for in-memory testing. Okay, so now that we've done that, I guess there's a couple things we can do. First of all, our client context is going to be broken because we no longer have the send system response. In fact, let's go ahead and do our client context first, because remember, we're going to have to update our client context and our MMO peer, because now both of these classes no longer match up with the iServer transport. That's all right. So in the client context, let's go ahead and get this all figured out. So immediately after I say if result equals null reference exception, and I extract the system invoke ID, I also want to go ahead and instantiate a response parameters, which is going to be a new dictionary of byte and object. So this local object right here, remember, we're in our invoke method on system method in the client context class in the server assembly. And so I'm going to instantiate this dictionary, which is going to contain all the parameters we're going to send as a response to the client. And now I'm going to fill it up with stuff. So I'm going to say response parameters, cast to byte. It's so annoying to have to do that. Operation parameter dot system invoke ID equals system invoke ID. Response parameters, cast to byte, operation parameter response is valid equals result is valid. Little discrepancy in terminology there. Not a big fan of that, but I won't make a big deal of it. Response operation errors equals result dot operation errors. And yeah. So now we've filled up our response parameters with all the things that are always going to be present, whether the response is valid, whether we have any operation errors, and the unique ID that will be used to invoke the correct callback on the client. Now let's change our actual invocations of transport. So in this if statement right here, we say if method return value equals response, I'm going to change it to transport.send operation response, and we're going to pass in an operation code of operation code.send system response, and we're going to pass in parameters of response parameters. All right. Now what we're going to do is down here, after we write our result to the serializer, or to the memory stream, sorry, we're going to say response parameters byte operation parameter dot result bytes equals ms.toArray. And then finally, instead of doing transport dot system response or send system response, we're going to do transport dot send operation response operation code dot send system response, passing in our response parameters. So now we're at a very consistent level of abstraction. It's also really nice because now this code, this client context class, can be instantiated in memory with an in-memory transport and do all of its behavior in the context of an in-memory thing without having to go and serialize, or not serialize, that depend on the serialization of other things. Anyway, so I think that just about wraps up our client context. Now we'll also have to worry about our MMO peer. So let's jump into our MMO peer class. Our send system response, and populate response parameters methods, which are in my file located at the bottom, are being nuked because we no longer need them. That behavior is now being expressed in our client context, and our MMO peer has become a little thinner, which is a good thing. So, what do I do now? I'm probably going to want to implement this method. So, all right. So the method we're implementing on MMO peer is going to be public void send operation response operation code dictionary byte object parameters. Well, now I don't need that anymore. And what send operation response is going to do is it's going to do send operation response. Actually, it turns out that the send operation response method is a method on the peer base class itself. So this might get a little confusing, but fortunately we have some distinctions in our parameter list, so we can make sure that we're invoking the overload that we want, which is the second one right here. So in this case, we instantiate a new operation response. We pass in cast a byte code, and then we pass in our parameters. And then on our send parameters, we pass in event.reliable. That's it. So that pretty much resolves our MMO peer. What else are we doing here? All right. So the next thing I want to do is I want to change some terminology a little bit. So what I'm going to do is I'm coming here to my event writer. We have this player init event thingy right here, and on one hand, I like having all of the player initialization be done in one place. On the other hand, I'm not a big fan of putting player-specific code in more... it's hard to describe. Basically, what I want to do here is... This gets kind of complicated. I guess I can just ignore it for now. I don't want to jump around. Well, you know what, whatever. It's not going to make too much of a big difference to anyone. So, player init, I'm going to change the name, first of all. I'm going to say, I'm going to call this, I don't know, something. What I want it to do is I want it to just contain a single component map. And I want it to be a message that is sent to any client that connects and has the RPC, system's RPC connected to it, which is going to be virtually any thing that connects. And so I want to do public event, let's do sync component map. And instead of receiving a server context, it's going to receive a component map. Then what I'm going to do is I'm going to remove these two lines right here and replace it with formatter.save bw component map. Well, we also need a way to identify which component map it is that we're working with. So I think I'm going to go into the base infrastructure namespace. I'm going to add a new enumeration that will determine which component map is being synced. So in infrastructure, or, we can just latch onto the event code. So the event code.initPlayer, instead of doing initPlayer, I want to do, or actually as the second parameter, or the first parameter to sync component map, I want to add something, event code. And then instead of doing event.fromDictionary event code initPlayer, I want to do just event code. And that's it. So now our sync, our initPlayer is now just sync component map. Then what I'm going to do is inside of our server context, I'm going to remove the player init event entirely from this class. So the server context no longer has a player init event. And then I'm going to remove it from the constructor. There are a lot of changes I want to, or not a lot, but a couple architectural things I want to do with the server context. We'll get to that later. Anyway, so that's all we need to do there. Now I'm going to go into the client context class. And when the client context class is initialized, what I want to do is I want to sync its systems component map that was passed into the client context. So in the constructor of client context, I want to do transport.sendData application events.sync component map, passing in an event code of sync systems component map and a component map of systems component map. Okay, we'll worry about actually going and adding that enumeration member a little bit later. So we do need to go into our player context, and we will remember that our send data method, our application.player and an event no longer exists. So we're in our player context, we're just going to remove that. All right, now we have two more errors. Okay. The first error is going to be inside of our client systems class. Remember how we changed the component proxy generator? Well, now I'm going to say create interface proxy without target, like what we changed the name to earlier. Again, I could have done all these name changes using Control-RR and ReSharper, but I wouldn't have remembered everywhere that they were used, so I wanted to just go through that process a little painstakingly. All right, we have one last thing to do, and that is to add the sync systems component map to our event code. So go ahead and click on event code and hit F12. Get used to hitting F12. Remember, if you click on something and your keyboard cursor is there and you hit F12, it'll take you to the definition. Get used to that, especially with larger projects like these, because I've been doing my best to like go, okay, now we're in MMO base.infrastructure. Blah, blah, blah. Well, it doesn't really matter where we are, because you can just click on this and hit F12. Or if you have ReSharper installed, you can hold down Control and click on it like a hyperlink. Or if you have ReSharper, you can hit Control-T and type in event code. Either way, what I'm going to do is I'm going to remove the initPlayer member from the enumeration, and I'm going to replace it with sync systems component map. That's it. All right, let's go ahead and run all of our tests. Make sure I didn't break anything, which I probably did because I break everything all of the time. And we get success. That's awesome. Okay, so that's about it. That's all the changes I wanted to make to the server. On the base infrastructure namespace, we will be adding another class in the next video, and then we'll be stubbing out our client, and everything will be super awesome. So we'll see you guys then.